Yeah, you were 111. So that's a little beyond this book, bro.
It's beyond the reach.
Yeah. Wasn't beyond, that's what you're doing.
See? I'm on chapter 111 out of every book.
Yeah. Trying to get those college credits, right?
Ask your mom to send an information.
I'm more capable of coming.
Yeah, me too.
We're all one big fan.
Except
Taylor, she's not nothing.
I can't be part of it. Because you guys are all, except me and Brandon. I don't have Brandon. Because we're the only
You're the one June.
June. Yeah, I think we're all. Bar mitzvah was? No. I had a bar mitzvah. Did you have a bar mitzvah? Yeah, of course. You're fine.
So what's going on with this? How'd you find out?
Brandon, are you Jewish?
Okay.
No, I don't think so.
Are you accepted?
Asian? That's not our religion. Asian is not a religion. Jewish, no, I'm Asian.
Okay, let's take a look at question 1 and 2 then. We're looking at the free response multiple choice questions. Okay, so
Out of curiosity, it's 2 free response and like 8 multiple choice.
yeah. All right, so we have how much faster are male swimmers and female swimmers. 5 male UCLA swimmers had an average time of 53.2 seconds with a standard deviation of 2.86. Another sample of 5 female UCLA swimmers had an average of 64.6 seconds with an S of 4.83. So what's an appropriate set of hypotheses? Well, we want to check and see that the male swimmers are faster than the female swimmers, right? So we should probably say which one's which, right? So let's say mu1. Yeah, that's going to be the average speed of male swimmers. Speed or time? We don't actually have a speed. We have times. So it's the average time of male UCLA swimmers, right? I think they wanted just to talk about male swimmers. And that would give us mu2. Yep. Female swimmers this time. And it's kind of important that we do this so that we can figure out which one's which. The thing about the UCLA that you're talking about, Jason, is although the sample is from UCLA, the question that I'm seeing here is how much faster are male swimmers and female swimmers. So not really anything to do with UCLA. That's just where the sample came from.
So would we get points marked off if we wrote UCLA?
It would depend a lot on what happened with your conclusions. Okay.
So if our conclusion states that it's not, if the whole population was,
Yeah.
then it would be fine?
Yeah. Okay. Correct set of hypotheses. Null hypothesis, and that should be pretty clear. Mu1 minus mu2 equals 0. And that's almost just completely formality at this point.
Always.
Pretty much, yeah. It's hard for me to say always because there could be an exception,
So what would the exception be?
but it's going to be really rare.
So not on the test?
I've seen it on the AP test. How about that? Like once, maybe twice. When what? Yeah. Yeah.
So this would be a difference of mean,
Yes, it would.
and it would also be a test.
It would be a test, yeah. Okay, so that brings us to the alternative hypothesis. So we want to see if male swimmers are faster, right? This is why this is a little bit of a trick question. If you're faster, is your time smaller or a bit larger?
Larger.
If you're faster, you have a smaller time. Time smaller. So mu1 should be smaller than mu2. If mu1 is smaller than mu2, this is going to be less than 0. So, trick.
Wait, so it's less than 0 because it's faster?
Yeah, because faster swimmers have,
But if they're asking slower, it'd be great.
yeah, have a lower average time. Right? Yeah. And that's what's tricky about this one. Okay, so to get our test statistic now, let's get to number 2. To get our test statistic, we're going to need, well, mu of x bar 1, x bar 2. That's going to be 0.
Let's say
Shorter time.
let's
If
say
you run the mile in 4.2 minutes.
let's say the player runs it at 40 seconds, you want to end up with. She's faster, but if you take one minus the other, it'd be less than 0.
Oh, wait, say that again?
Let's say you run a mile 40 seconds, she runs it. It's because it comes out negative. So less than you minus you, it'd be like minus 20 seconds. Even though you're faster.
Which is less than 3.
So we get a square root of the male time, which was, or male S was S 2.86. 2.86, we're going to square that. And then divide that by the sample size, that's 5. Plus, now we're going to square the female's standard deviation of 4.83.
Oh, the 2.86 was the...
2.510, I think.
Oh, right, that's the formula. Probability squared over n plus probability.
Not probability, the standard deviation.
Oh.
Standard deviation.
What?
Is it point?
What's that?
I got 0.919.
Check to make sure that you have parentheses in the right place.
What is that?
No, that's
Did you get it? Did you get it? I probably did get it.
Use the fraction key. Yeah, that's going to help you out a lot.
That's right. You should use this method of standard deviation when it's a mean and standard deviation is supposed to know.
Standard deviation of the sample should always be known. And, you know, to tell you the truth, this should be approximately equal to, because it's exactly equal to the population. I'm not going to go through the conditions here because it's really irrelevant if we're just going to compute things. Yeah, exactly. Multiple choice, we're just computing. So then we can get our, this is going to be a t statistic, t star. And it's a t because we do not have a sample standard deviation, I'm sorry, a population standard deviation. And it's a star because we're doing a test. That's going to be x bar 1 minus x bar 2. Minus mu 1 minus mu 2.
So we use it because it's not probability and what?
Wait.
We use t because it's not.
We use 2 because it's yeah, it's a mean.
Yeah.
Sigma is unknown.
Sigma as in.
Sigma is unknown.
Is it the same? Is this equation of z star?
Sorry, I'm totally messing up here. Mu of x bar 1 minus x bar 2.
Can we all check at the same time? Like today's session, so you get one right now. Just let me know. I guess we're not working this morning. They probably didn't get in. When?
Yes.
Did you get in?
Yeah, I don't think just because it's based off GPA.
Okay, we know that one of these quantities is 0. Let's go ahead and figure this out. We have 53.2 for the male swimmers. Female swimmers is 64.6 minus 0 divided by 2.510. Negative 4.54. How many degrees of freedom do we have? Sample of 5 and a sample of 5. Degree of freedom should be 4.
Because it's 1 minus.
1 minus the smallest sample. Okay, and let's get to the calculator. I think I have people who kind of aren't getting the standard error correct. So we really should leave that indication here. How do we get that standard error? Well,
Isn't it just the second step?
yeah, well, let's clear this out for a second. We're going to take a square root of, and then I really recommend you use that fraction key. Oh, I think this is pizza. Hello? Okay, I'll send someone out to the front of the school. Thanks. Who's gonna pick up pizza? Pizza pickup? Pizza pickup?
Dude, sure, why not? Is it, wait, where did I go? Just main office?
No, in front, the front entrance of the school.
Oh, okay.
Yeah. Teacher parking lot, front entrance curb. 2.86 squared over 5 plus, and then again, try to use that fraction key. 4.83 squared over 5. So that would be how I would do that standard deviation. It's sigma for the sampling distribution. Okay, there are many different sigmas. So this particular sigma is sigma of the sampling distribution. Okay, let's clip that and put it here. That's how we got the standard error.
But isn't that the same as standard? Oh.
Okay. And then our next one would be to get the p-value. Yeah.
Can you explain again why it's T-star? It's because there's no population deviation and what else? Why not T-critical?
And it's star because we're doing a test. Okay. So maybe we should write that down. T because sigma is unknown. Thank you.
So now it has a chance to get away.
Star because this is a hypothesis test.
Now, I have a question. Is the formula different if it was a mean and you're finding the confidence interval? Like for sigma?
No.
Is the formula different?
No.
It's the same.
Same formula.
So,
Different formula if you're dealing with proportions.
what's that? Well, that's the PC one, right? And then the P. Okay. So there's technically only 3 formulas
Yeah.
for sigma. Got it. Thank you.
Okay, next one is a p-value, and hopefully you guys got that p-value ready. So the p-value is equal to the probability at t is greater than, no, less than negative 4.54. And I'm not going to bother with the calculator. We should know that that's about 0 already.
Is it always just to be about 0?
No. It happens to be about 0 because 4.5 standard deviations is really far away from the mean.
So if it's like 3 out of it's usually about 0.
Yeah, usually about 3.5 and up you would go to 0.
Okay. Nice to know, but still check if you don't know.
Yeah, if you're unsure about 0, then, you know. All right. That's my p-value decision. We're going to reject the null hypothesis. Okay. They're not asking for a conclusion, so I'm not going to bother with a conclusion. But you should know that the conclusion of this would be that since we've rejected the null hypothesis, that means we conclude that the average time for male swimmers is less than the average time for female swimmers.
Can you explain? You were saying something about standard error. What is standard error?
Standard error is a standard deviation of the sampling distribution.
So, what's the difference from
Standard error is basically standard deviation that takes the sample size into account.
But so in this case, it's the same as the standard deviation, right?
What do you mean by the same as the standard deviation?
As the population, the sample distribution, sample standard deviation.
Well, here's the thing: is because we're doing a standard deviation with sample sizes,
Yeah.
we call it a standard error. Okay.
Oh.
The other thing is because we don't know sigma, we have to actually approximate.
Okay.
So this is approximately sigma x bar 1 minus x bar 2, which would mean that this is approximately our standard error.
Okay. So if you have a population,
Same formula, it's just that instead of using S, you would use sigma.
okay, and that would be different. That would
Doesn't change
that
the
would be-
formula at all.
But would that result in a different number from the standard deviation we calculated?
That would probably give us a different number, although it's maybe not.
Okay.
Okay. Okay, let's go on to question 3. Oh no, we have pizza, right?
Yeah.
All right, pizza time, everyone. Pizza time. Pizza time.
For the 83,
Yeah.
for the chair 83, is it lower bound, upper bound, degree of freedom?
Lower bound, upper bound. That's it.
Oh, no degree of freedom?
Oh, lower bound, upper bound, degree of freedom. Yeah.
Yeah.
It's like my first choice.
Hey, pizza time, pizza time, pizza time, pizza time, please. Do the pizza now, pizza now.
This is so bad. I said I wouldn't.
Could you bring that over there?
But like, give me your money and a change.
Also most expensive.
Is it just cheese?
Who's the manager?
That's mine. Sorry.
We're all just cheese today.
Cheese on cheese on cheese. Really good. U of A, Oregon. Thank you. Slow. And then like San Francisco, Fullerton, Northridge. Fullerton, yeah. I didn't apply to any UC. Because I knew I wasn't gonna get.
You didn't apply to any UC?
Not one.
You would have gotten in. Yeah, you would have.
Did you get into apply to any UCs?
For a lot of UCs, that you
Weighted or unweighted?
Wait, what now?
oh, are you going?
You got into SB?
Yeah.
You're not gonna go?
When did you find out? She got the top straight.
Oh my god, good job. Wait, considering it.
Is that weighted or unweighted?
Yeah, but you don't. Wait, see, it's a system.
Thank you.
No. My
Killed it for me.
I elevated my leg.
My situation is this is very out to me next
I'm
year.
a Spanish speaker.
But
We need Spanish since
I can't imagine myself being like,
Really? Why is that?
I go to
I don't know, I like the USC type of look, you know what I mean? Like the old
Oh, really?
and you see it's super like modern, eco, like
Yeah,
it's
yeah,
nice.
I got 5 on the test.
Yeah.
5 on the test. 750 on the SAT. 760. That's not to be even good. She literally
I figured out with extra toppings. This is a two-topping meal.
Okay.
because
So
I
you
got
have to like
she
share.
only hole in my
Is that why it's like falling out of the thing?
I
Got
don't-
extra cheese?
Don't take Spanish.
Yeah?
But also,
I did.
I don't have money.
so I was
You wanna borrow it?
today.
Just right now.
Right
You work in
She sells food at the gym.
I sell food at the gym.
I'm good.
I'm good. Babe.
Yeah. You would have gone all day. Yeah. You would have
I
gone all
will
day.
actually offer my money.
Yeah.
I have
I don't have my
I mean, if you're giving money away, I'll take it.
I was so mad and like scared.
It's for Adam, I don't care.
And if I took Spanish and I got all the elite, which I had all she needed me to say 2 C's, then I would no, this girl, this teacher gives me 2 C's and it's like that's crazy. But yeah, I didn't have any lower saying health, they don't have anything for public relations and I applied.
Let me get a key.
I applied to Ithaca, but it didn't like the wrong time.
Who's Bromell one?
Like Midwest. Midwest is still good. Then I got
Pick a calendar.
it's
Oh.
like
But Daisy, what's your number one? Where?
I was thinking that.
Where?
Berkeley. I had interviewing.
She's interviewing for a full scholarship.
She topped in her class?
Should I get another one? I don't know
I do work, right?
Number 2.
Who's
Wait,
topping
I
her
need to
class?
ask him a question.
Excuse
Excuse me. Where'd he go?
Who's
Bathroom?
topping your class?
Answer accidentally.
Did he go to the bathroom and he looked and he didn't say anything?
You're really stupid. You're very He thought I was an idiot too.
Yeah. Told Taylor. Well, you thought I was an idiot.
To tell me.
Oh, that's
Who?
Oh yeah.
You got a free show, come on.
That you weren't really.
No, I honestly did not. You were talking about me.
Up.
You're number 20.
Sorry.
crazy for the big.
Otherwise it's tea.
Roy,
No.
what SDSU?
Like sometimes it says assume like I wish we assume that's S or do we assume that's
Oh fuck.
My sister.
I would assume it's unless you have really good evidence that they actually use it.
okay, because on the last test
Are all the people that are probably going to get a media, you know,
and
they're not going to take 23 people
I didn't know what
you're not going to
yeah,
get. That's exactly why. The little
You have to really seem to talk about the population.
What was his ranking?
it's hot, it's S.
My brother, he told me, like,
Helen, if he
before I
was
bought-
12 this year, he would be number 100.
I know. No, but he went to a magnet school.
Are you
But
ranked, like,
I
top?
told, like, before I got my SAT scores in, he's like, you didn't study this time, you were probably going to do worse than you did last time. I'm pretty sure you got, like, this time. And, like, so
Why do you have garlic sauce?
So, and then
You're messing up. You're messing up.
I run into the
English is gonna be top
bathroom,
work
I got a 28,
Years ago,
bitch, and then I run out.
Is there a bathroom open?
I don't know. There's no phone.
I need, well, like you can try to fit No. Hang on. Is there a bathroom?
Okay, so what's the prank are we performing on her?
You see, faculty. Let's go to the faculty one.
Senior prank we're performing on her.
They're still coming. Wait, we have to check
I'm
out
thinking,
shit.
I'm thinking just board up her room.
Anyone else?
Not only needs toilet paper. No, I already
She's
went.
everything.
literally
What is she
hates
like?
everything.
That's the question.
I don't know.
I got a 328.
Now looks the same. No, wait on
Now I have like a 4.2.
Last semester I got like a 4.1. I had 4 AP classes.
Yeah, last semester I did really good. I got
Really
1B.
well, last semester I did really well.
I know, not last semester. Wait, no, never mind. Last semester I did.
Last semester waited.
I got a 4.1.
Last semester,
terrible
what's-
last semester.
what's-
when you write
wait,
something-
Yeah, last semester I did like a 4.1.
Waited or
No,
unwaited?
she does, no,
Wait.
but you can, but like, no.
That's
a little higher.
because I got straight A's.
Yeah.
Gov, AP Gov,
You guys can't do that, right?
Well, I mean, like, from person to person, you use texting, and they understand how, like, formally you're supposed to write, sort of, this is what it looks like.
Yeah, same as ours. Yeah, I don't understand it at all.
Your parents can be there? Can your parents be questions? If they want to.
You can understand your two songs, but the thing is, you understand me.
You understand
No,
us
I
more than
understand
we
you,
understand
yeah.
you.
There's napkins over there, bro. There's napkins over there.
Andre, not like fluently, but if I speak, she can understand what I'm talking about. And I can generally understand what you're saying.
That's cool.
Did you check? Andre, did you check?
I can't, I didn't get an email, so I have to check my web portal, not for the password.
Oh, you don't know.
We said it.
You know what I wonder? So I wonder how long Twitter is going to be a thing.
I think it's here to stay, to be honest.
I think it's like.
See, they said the same thing about Facebook.
I think MySpace is coming back. I think it's coming
And
back.
they said the same thing.
No, so Twitter's already dying down in my opinion. I think it's already dying down, so.
What's next?
We have to find the next one and invest in it now.
You know what?
That's-
I'm making it. I'm gonna make it.
It's not going to be Pinterest, that's for sure. LinkedIn, no. It's not going to be LinkedIn.
Yeah, for you. When you become a businessman.
Ready.
What is it? Is LinkedIn?
When you own half of LA, I'll call you.
You call me only then?
No, I'll call you after.
Why he doesn't know already?
Not if it's 49.5%.
What is the probability?
Yeah.
I don't have it.
Well, what margin of error?
Yes, let's do that.
What's the margin of error for the percentage of Los Angeles that Adam owns? Does it include 50%?
You know what's sad? It's actually possible.
Yeah, that could be the beginning. Sharon will only speak to Adam.
What is the probability of sharing that? I'm not like that.
I would actually not like really think that's.
You only have to own half. You only have to own 5%. That's it. That's it.
Sunset Boulevard, it's Sharon Boulevard.
It depends on which 5%.
Yeah.
It depends on which 5%.
And then there's like Rodeo in Wilshire 5%.
If you own a new Wilshire, I give you an extra 10%.
Thank you for waiting.
Mm-hmm.
What's up?
There's no toilet paper.
Again? They literally just cleaned the bathrooms. I don't know how they can. I wish I had my kids to do one. What is around your neck? You need a bus shoes or heels? They were just trying to get it. I ran out of water. You could. What?
Does?
And from senior activities except for drama.
They can go wrong.
I don't feel it.
I mean, technically, who? Just like think about it. No, it does work. What happened?
Okay, let's take a look at 3. Let's get started. Oh, Harrison Ford seriously injured after crash landing a small plane into a golf course.
Oh,
What?
I know his son.
Indiana Jones.
No.
I know.
He should have taken like his whip and like
Wait, are they
jumped
making
out
the
and
Indiana
just
Jones
done some
movie?
crazy. I don't
It's
know.
okay, he's not dead.
Seriously injured. He's an old man.
That's bad. I thought you said minor injury.
No, seriously injured.
Oh wow.
I worry.
Oh no.
That's sad. Oh my god.
So he was.
I think he was flying a plane and he crash landed.
I hope that's not.
Guys, I'm about to find out if it goes down.
I was like,
Because they only look at your balls and your GPA. They don't look at, there's no essay, they don't look at your, like, extracurriculars, it's like stupid.
Okay, let's go to 3. That's Han Solo, man. It would never happen if he was flying the Millennium Falcon.
So, do you have just a charger?
Just a charger?
Little, like, plug.
Oh, no, you could just get with the blue cord and plug into the blue cord. No, no, you don't need the charger. Just put the phone in the blue cord. You don't need the charger. You don't need the charger. Just, yeah, just, oh wait, yeah, just plug it into that. Yeah. It works really well, too.
I got this like portable charger from like this really random like downtown LA festival, and they can't even find it like in stores. If I search the company, like it doesn't exist. But like it charges my phone like 8 times with this one little box.
Oh wow.
Before it dies.
Nice.
More than 3 of the same type of character in a row. Does that mean uppercase, lowercase, all that?
Yeah, if you have 3 lowercase letters in a row.
Dude, what's a name? What the hell do you
Put one lower, those are the worst passwords.
You think I'm gonna remember that?
Those are the worst passwords.
Okay, let's do this. You're constructing a 90% confidence interval for a difference in proportions. We find that x1 is 12, n1 is 25, x2 is 15, n2 is 12. Standard error, margin of error, and confidence interval. Okay, so let's get all of this out of the way. The center of the confidence interval is going to be mu of P1 minus P2. That's going to be equal to, we need P1 and we need P2.
Yeah.
So P1 is going to be equal to, what is that, 12 out of 25?
You got it.
48%. While P2 is going to be equal to 15 out of 38.
40%.
No, dude, I'm just, I can't figure out how to plug this.
Yeah.
Just seriously, maybe just write it down. I have to reset mine.
Everyone sharing.
Okay, that's great. We have that. Mu P1 minus P2, that's going to be 0.48 minus 0.3947. It's 8.5% about. Yeah.
Could you also put mu pi 1 minus pi 2?
Yeah, I'm not gonna.
So you're subtracting them because it's a confidence interval, right?
Yes.
If it wasn't, then you would do equals 0, right?
Yes.
Wait, why would
Wait, can you explain again? So because the confidence.
Because it's a confidence interval, we don't have a hypothesis.
Oh, we're not testing a hypothesis. Thank you. Okay.
We're not testing a
I
hypothesis.
get it.
So we're not hypothesizing that the center is 0.
Yeah.
Sigma P1 minus P2 That's going to be equal to the square root of P1, which is 0.48 times 0.52 divided by 25.
Is this the same formula that S1 over
I'm gonna put the formula up in 1 second, so I think it'll make more sense. This is going to be equal to 0.3947 times what is that? 6053 out of 38.
How is this supposed to look? Like when you write it out?
On the calculator, the way that would look is,
Okay, it wasn't like my first choice.
let's see, the square root.
What's for volleyball? So, like,
No, not 7. Square root of 0.48 times 0.52 divided by 25 plus.
Mr. Freya, I think you messed up the fraction.
Where's that? Oh, I forgot the times.
I'm gonna do an error thing.
Forgot to multiply.
Yeah.
Thanks. That would have been embarrassing. Another fraction bar. And I forgot what this is. 3947 times 0.6053 divided by 38. And that should give us our same standard deviation. So that's the way I would do it on the calculator for sure.
Thank you.
I'll put that in the notes also.
It's so confusing when you're like writing it out and I don't know what it looks
Yeah, I understand it.
like. It's like I don't know like where the divide, like some of them there's dividing inside of the
Yes,
area.
I totally understand. It's hard to read when it's all in line like that. So, which is why the TI-84s work really nicely now, is because you can get those fraction bars and it looks beautiful.
So where would we round it to the fourth number?
Definitely round it to the 4th decimal.
How do we like know when to do the fourth and when to do?
If you're doing proportions, everything's on the 4th decimal.
Okay.
Okay? Okay, the next thing we need is Z star, right? Well, I'm sorry. 3 is supposed to be the conditions, right? However, since this is multiple choice,
do we just find those tests?
we'll skip conditions. Okay. The next thing we're going to need is now to calculate. So the first part of calculations, Z star.
It's because it's
No,
proportion.
Z critical.
Why is it critical?
Okay. So it's critical. No, Z because Z critical because
So Z because it's proportion and it's critical because it's a confidence interval and not a hypothesis test.
perfect.
What?
Z because it's a portion, critical because
It's
confidence interval.
So it just says that in the question. That's how we know.
Yeah, I know.
Mr. Freya, I have a question. So, if there was a problem, a multiple choice problem, where if we did test the conditions, it would come out as it does not follow, it does not meet normality or whatever,
Mhm.
What's your first
would,
choice?
and there was an answer that was like none of the above, would it be none of the above?
I wouldn't do it.
You wouldn't do that?
I wouldn't do it, yeah.
Okay.
I wouldn't do it. If it was none of the above and then had a reason, then I would do it.
Okay.
All right, so let's calculate that Z critical. That's going to be equal to an inverse norm calculation.
So for step 3x, I know we're not doing it, but what we would do is we should do anything you want greater than
Right, so we want a 90% confidence interval, and that would be from programs. Program to use here is inverse norm.
Wait, why not inverse T?
Because it's not T, it's
Oh, it's
C.
these. Sorry. How do you know when to use Z star then, and not Z critical?
Star are for for tests.
For what?
A test.
And then right now we use the program to
Mhm.
find what the.
Z critical.
Oh.
So,
So you do
so if it
inverse
was Z
norm.
star, we would use the P1 minus P2 minus. Okay, but if it's critical, you just do it in.
Program, yeah.
And we should use your program. We don't have to do the 1 minus and then the. Okay, so you just put in the.
If you're using a program, it's really easy.
Is it an interval or a test?
Interval.
Just try to do this for me.
It's that, like, if it was a proportion, we would use actually
Oh, so you same thing, just P1 and P2.
Okay, so maybe at the conclusion of this problem, we'll try to summarize all of this for you. Okay? Yeah.
If it was T critical, would you use the inverse T?
T critical is inverse T. Yeah.
Always?
Okay. Let's get to the margin of error. Margin of error is going to be equal to Z critical times the standard error.
Oh, margin error.
P1 minus P2. That's 1.645 times, and I forgot what it was, 1276.
Is that supposed to be Z critical times standard?
Yeah.
6, not 5.
Oh, 6?
Yeah.
Sorry. Did it change?
Yeah.
I don't like the way this looks. That's better.
Wait, so just to make sure, there's 4 tests in the top. There's
6 tests, actually.
I know.
Huh? Let me finish this and then we can do that. Let's just try to stay focused on this, okay? Margin of error, what's next? The interval? Interval.
Wait, so the standard error was the Z critical?
Standard error is, no. Standard error is used to compute Z critical. No, wait, hold on. The margin of error is Z critical times standard error.
Oh, so that's how we're going to find standard error?
Yeah.
Oh, okay.
So our interval equals mu P1 minus P2 plus or minus margin of error.
.08.
0.0853?
Yeah.
Plus or minus 0.2099, yeah.
And then you get 2 answers.
Mm-hmm. Now I don't know what they are, but I'm sure I can compute them real quick.
Yeah, so lower so what 1% of the actual value between
Negative 1246. $2952. Thank you. That's our interval.
Since it's multiple choice, we don't need to worry with the negative, but otherwise, we are 90%.
Yeah. Otherwise, we are 95% confident that the difference. 90. Okay.
90, because that's what it says in the question.
Okay, so let's go over some summary things here, since we are on it. What T is for means only. Z, proportions, and means if
We know the student.
yeah, sigma is known.
And usually in the question, are we going to be given S instead of, and then we define
Yeah, it's more likely that you're going to get S than
And then we
sigma.
have to do that formula.
Okay. Critical are for confidence intervals. You found using program or inverse T or inverse norm. Most of us are on the program, so I'm going to underline program because that's what most of you are doing.
Isn't it depending on whether it's T or Z?
Yes.
So T inverse T.
Yeah.
Or what about program?
Yeah, the program inverse T or the program inverse norm. There's also calculator functions called inverse T and inverse norm, but I don't recommend you use those if you can avoid it. Lastly, stars. Are for hypothesis tests.
And that's, it states that in the question.
Yeah. You find these numbers using what would be the appropriate equation?
Well, for
Oh, isn't it?
T, it's x bar 1 minus x bar 2
Yeah.
minus mu 1 minus mu 2 divided by sigma x bar. Well, x bar.
X.
I think as long as you organize everything, it's not. You just have to organize it. Like last chapter. It's just so hard to get it. So once I want to put the word to organize it,
Yeah.
Okay.
And then if it's Z, it's just P1 minus P2, right? Instead.
Sorry?
If it's the Z star, you just change it to P1 minus.
Yeah.
Okay, so it's like the same thing. Just
Mhm.
and then, but it's still M1 minus M2.
Yeah. All right. So that should help a little bit. Hopefully.
So this is not sigma
Okay. Yeah.
Just curious.
Mhm.
You know how like you made those programs for us?
Yeah.
What do people do that don't have the programs?
They have to learn how to use inverse T and inverse norm.
Yours has it, right?
It's not difficult, but it's just more equations for you to memorize.
So, if you were to do that, the area, would that be like if you're doing inverse T?
Yeah.
The area would that be like?
It's usually half of the let's just say that the confidence level is 95%.
Yeah.
So then it'd be half of 5%.
Oh, because that's your area on one side of
Yeah,
the normal curve.
exactly.
Oh, that's
It's not difficult. It's just
It's just conceptual.
yeah, exactly,
It's easy.
exactly. And since we have a broad spectrum of students, best just to do it that way. Okay, let's move on then. We're on number 4. An SRS size 200 is taken from a population proportion 0.7 successes. An independent SRS of 300 is taken with a sample proportion of 5. The sampling distribution of the difference in sampling proportions has what mean? That's a very, very lengthy question, but all they're asking is what is mu P1 minus P2?
So whenever asking for mean.
The mean of the sampling distribution is mu whatever.
Why is it P? Oh, proportion.
When would it be
Stacy?
5 is mean?
Okay, for stars, we use CDFs, right? Like normal CDF.
Yep.
Yeah, that's P.
Maybe I should put that here. P-values are computed using T star or Z star and a CDF function.
Standard error is the
Gosh, I hate going back and forth like this. All right, so this is pretty easy. It's 0.7 minus 0.5. 0.2.
That's all it's asking.
Yeah, that's all it's asking.
That's a good problem.
All of your multiple choice problems should be calculated.
But they're not. They're gonna do like
Taylor, no. They should be.
See,
pretty similar.
you know, a lot of what makes stats difficult is some very highly specialized vocabulary. Yeah, and interpreting that highly specialized vocabulary.
Reading that question, I would have had no idea.
Yeah, I know.
Did you?
Legit. Though I was looking at it and like, okay.
I would have done like the whole hypothesis test or something.
Okay, continuation of problem 4. The sampling distribution for the difference of sampling proportions has what standard deviation? They're asking for the standard error here.
So it is the same.
Okay, so yeah, I was gonna ask standard error and standard deviation, are they like the same thing?
Yeah, the standard error is a standard deviation of a sampling distribution. Basically, standard error means you're computing a standard deviation, but taking account the or taking into account the sample size.
Standard error takes into account the sample.
Yes.
Not population.
Oh.
P1 minus P2. That's going to be equal to, and maybe I should just do this on the calculator, because that's going to help a lot. Let's clear this out, and square root of the first sample is 0.7 success. So 0.7 times 0.3, sample size is 200, plus second sample has a success rate of 0.5.
So
300.
The error.
Can I just?
Yeah, sure.
Can I use the S1?
Mhm.
When do we use this one? When do we use PC?
PC if you're doing a test.
No, wait, when do you use the S1? Is that just, that's for mean?
That's for mean only, yeah.
What do you mean by when you're doing the test?
Because remember it's S1 over square
No,
root
no,
of
not for that one.
I'll
For
show
the
you
PC
guys.
one? What do you mean?
PC is if you're doing a hypothesis test.
So this same problem was a hypothesis.
We would use PC.
Okay.
but since it's a
Wait, so it's P1. It's this formula because it's a proportion.
It's proportion and it's asking to estimate and not asking you to test something.
Takes a while.
It's test PC.
You would use PC, yeah. And truthfully, PC and this number should be pretty close to each other.
Wait, you said it because it's asking for a sample?
It's estimating.
Because, yeah, you're estimating
Where
here.
does it say estimate?
Is it just that it's
Pretty
not
much if
asking
it's-
test?
If it's on
Yeah,
multiple
it's just not
choice-
asking you to test anything.
If this problem's on a multiple choice, we would use this format. If this same question was like an FRQ, we'd use PC.
Well, no, it'll
No.
ask for a hypothesis.
If it's a hypothesis
But, yeah.
test.
Proportion.
See, they're not in this one. They're not saying test if one proportion's bigger than the other.
But like this formula is for the S1 squared over
Okay.
N1. That's because that's a sample.
That's no.
So it's
Well,
mean.
that's for a
Well,
mean.
that's what I mean.
Yeah. Okay, so what do we got? 4, 3, 0, 4, 3, 4.
What's the formula for this?
This is the P1
What is it? Square.
0, 4, 3, 4.
times 1 minus P1.
Let's get this screenshotted in there.
Well, this is like, okay, so like, sorry, all over, like, that thing's all over N.
Oh.
N1, yeah, plus P2 times 1 minus P2 all over N. That should be,
Proportion.
that's,
Bless you.
Yeah, there were 4 and 5 were considerations.
But that's what I don't get, isn't the P1, you use that for confidence interval? This formula?
This is, yeah.
And you also use it
Also use it for.
This.
for this.
Yeah, well, this is the way this looks like. If it's not a test, it's an estimation,
Okay.
which means confidence interval.
Oh.
This is
So it's always either or.
It's always either or, yes.
wait, so this is a confidence.
Yes.
This would be for a confidence interval, yeah.
Okay, and the one with PC is hypothesis.
Yes.
This is very good.
This is what?
Only use PC for a confidence interval.
What? No, for a.
Hypothesis test.
Yes. But then, no, you can't do that.
No,
You can't just change that.
Sorry, for a different.
So confidence interval would use this.
Can't just change on me like that.
I wish that C meant confidence interval.
I know.
It would be a lot easier to memorize that.
Well, that's how I'm gonna remember it.
The C is not confidence interval.
Somebody's not gonna
That's what I mean. Like PC.
Freshman. Should have some health class.
We should have a
It's okay.
No more pop quizzes.
no fake quizzes.
You just should have passed all your A's.
Wait, it's P1.7
P1.7, yeah.
and P2.7.
Yeah.
Did you have the last test?
Not good?
No.
Okay.
No. What? You wanna know why? I got like pretty much all right and then but like 4 wrong and a little.
Is the sample size for both 300?
No, the first sample size is 200. The second sample size was 300. Yeah.
So the difference of proportions.
Difference of proportions. Thank you. The C is not for confidence interval.
There's like nobody here.
I know. Well,
In some schools, this is the size of their AP science class.
In some schools, this is their size. In most schools, this is the size of their AP stats class.
There's no one here.
Okay, let's get to 6 then. 6, we want a 90% confidence interval for the difference of means. N1's 15, N2 is 29. X bar 1 is 12, X bar 2 is 16. S1 is, wow, that's a lot of stuff. Assume the conditions are met. Let's calculate standard error, margin of error, confidence interval for the difference of means. Good.
Also, it was before digit for that one, right? Fourth line.
Yes, because we're doing
But this
p's.
is a mean, so this isn't proportion.
So let's start off with a standard error. Sigma, no. Let's start off with mu
And it's just
of
a-
x bar 1.
There's no hypothesis. Do not
So
use
we're not using PC.
Yes.
Wait, what?
Since it's a confidence interval, it's not a hypothesis.
But
Do
we're
not
using.
use standard error.
This isn't even a proportion. So
What does that even mean? Yeah,
no
we're using a mean.
proportions.
So
we're doing a mean. So there's no
P.
c. Yeah.
What does that mean? Do not use the standard error
No, let's remember.
for that. No, what does that mean?
Let me swear. Do not use the standard error.
For the hypothesis.
Wait, since this is a do not use this.
Do not use
Yeah.
the PC.
Oh, do not use PC. Okay.
Don't use the standard error.
Oh, since there's no hypothesis.
Okay. Thank you. That's very
Does that make more sense?
Yes.
All right. So, okay, so we got 12 minus 15. 16? Okay.
Is that a negative one?
It's negative for you. Sigma x bar 1 minus x bar 2. Equals. Let's do this on the calculator over here.
This is gonna be T star. We already know, right?
This is definitely going to be T star, yeah. All right, so let's clear this. We need a square root. That's not a square root. We need a square root. We need a fraction. And that's going to be S1 squared, which is
Wait, I want to see.
8.5 over N1. N1 is 15, yeah, thanks. Plus
Oh, yeah.
Okay, no, but I meant up to.
fraction bar. S2 is 4 squared.
Over 29.
You said 29, yeah? There we go. 2.31, 2.32. Screenshot that.
And what's the 12 and 16? The
That was the
mean.
standard error.
12 and 16 are the,
Negative 4. What is that?
that's the means. X bar 1 minus X bar 2.
And we always have to do that first.
Yeah. 2.32.
Oh, that's different formula. That's not the
Ooh, what just happened?
So isn't that standard error?
And standard deviation.
That is a standard error.
Because standard deviation and standard error are the same thing.
Mm-hmm.
Check the standard error. Margin of error. So now we're doing confidence interval.
No, we have to do step 3.
Well, since it's a multiple choice, step 3 is not something we need to do.
What
I
would
think
step-
it-
What would step 3 be?
Step 3 would be to check that the formula's conditions are met. So you would check to see that the populations are more than 20 times the sample sizes, and you would also check that either we have a normal population,
Is this just like the last condition? So it's graphing
not-
and the.
yeah, graphing, or either large samples, normal population, or
Large sample, normal population, and.
or
bigger than-
samples don't deviate from normality.
Yeah, yeah, and then it's bigger than 0.05.
0.05.
Or 20%. Which
20%, yeah.
So this isn't the greater.
Population is bigger than 20 times the sample.
So this isn't greater than 10.
This isn't greater than 10. Wait, what?
Like
you know how for step 3 you have to check if like N1
Oh no, that's for proportions.
only.
Only for proportions.
So for this, that's what I was confused. So for this one, for mean, what do you use? For
Means are the three things. Okay, either normal population,
Okay.
or large sample,
Okay.
or you check the three graphs.
Oh, what about population bigger than 20? That's a large sample.
That's for the standard deviation formula. That's an additional thing you need to do for. You should always check that one, that the population is 20 times the sample. Bigger than 20 times the sample.
Does that have anything to do with the 0.5 alpha?
0.5, no.
Okay. What does that have to do with?
That has to do with the
P-value.
standard, wait, which one?
When it's
0.05 is p-value, typical p-value, yeah. I know it's a lot.
Okay, so this is what I'm confused on is for the step 3 for mean.
Mm-hmm.
So you check the graphs, or if it's a normal population,
Yeah, that's different.
and
Or
large sample.
large sample. So how would you rate it?
well, in this case, we don't have a large sample. We're not told about the population, and we can't check the graphs because we don't have any information to check. Okay.
So that's the hash rate.
Now, how do you know it's not just a sample just because the numbers are big?
30 or more.
Yeah, 30 or more is a big sample.
It has to be for both.
So that's why this one doesn't even.
Yeah.
Okay.
All right, so let's get back to the standard error is 2.32. Good. What's next?
Margin of error.
Margin of error. So for margin of error, we're going to need a T critical. Okay, and then we're going to get that from. We're going to get that from our program. Criticals come from programs.
So inverse T.
It's not an
So the inverse T program.
Oh, okay.
critical always in
Confidence interval. How much confidence do we want? 90. Good. What's my degree of freedom? What's the smallest sample size? 15. So our degree of freedom is 14. Ooh, it's really thinking. 1.761. Let's clip that here. Great. T critical is 1.761.
Increasing the confidence level
Mhm.
increases the range for.
Increasing confidence increases the interval, yeah.
So like 1% confidence would be like very small.
Very small, yeah.
And 99 would be relatively big.
Yeah. Margin of error is next, I think.
Yeah.
Margin of error. Margin of error. I keep going back and forth. Does Mo look better or does ME look better?
ME.
Okay. That's T critical
Wait, what is this? Is this for margin?
times standard error, right? What is that? 1.761 times 2.32? 4.09? So our confidence interval is going to be equal to, what did we get for the center? -4? -4 plus or minus the dog?
Huge.
There you
Either
go.
English Mastiff or Bulldog. Like,
Wait, what am I doing here? Negative 8.09.
What's the 1.761 that we found? T critical?
T critical. Yeah, that's good. Is that everything for this one?
Better be.
I think so. Better be. All right. 3 more to go.
Are we doing FRQs?
No, we're going to do FRQs in class.
Okay, good.
7.
No, like, I have to leave.
Are unemployed more people more likely to commit a felony than employed people? 5,000 employed and 20,000 unemployed. 5,000 unemployed. I was going to say these numbers are backwards. 5,000 unemployed and 20,000 employed people are observed for a year. Which test or interval is most likely going to be used here? So do we use a test or an interval, do you think?
Test.
Test. We're trying to show something.
So hypothesis.
So it'd be an interval if maybe
Trying to prove something.
Why not interval?
Not estimate. We're not trying to estimate, you know, what percentage of, yeah, exactly, or the average number of felonies committed, or, and you know, for this one, you could kind of go either way here with proportions or means. I'm not sure what, well, no, let's see. We're just counting, right, the number of felonies?
it just says, is it greater than, is it more than?
No.
So,
Would this be a proportion?
So I think this would be better for proportion.
Because like, it's like the proportion of unemployed. And
Yeah,
we could argue either way.
there is a way to argue it either way, right?
So on the test, would you give us numbers like wouldn't it be better to give us all the information we have and then ask us the questions whether we use like if we're gonna use a proportion, wouldn't it be better to say 70 out of 5,000?
Yeah, exactly.
5,000.
That's what we would do. We'd say 7 felonies out of the 5,000.
Yeah, but so that would be
That'd be a proportion.
of course. But on the test, would you give us a problem more like that or more like this? And say, do you use a test and a proportion test, or
Either is possible.
What? Griffin, what did you ask him?
like would he give it something like this and just test and say, ask us this question? Would he give us like 7 out of 5,000 unemployed people committed a crime? To give us more information, so we know.
Seven
There's
out of
not,
five.
there's not really a argument either way.
So this would be a hypothesis test for a difference of proportions. It says 2 sample proportion tests in the back, but
so first we do the.
Wait, why did
Do
you
we
make
know
a
that-
hypothesis test for a difference of proportion?
that's what we would be doing.
Oh, okay. And it would be in confidence interval
If we,
it,
go ahead.
like, if it asked us, like, the percentage.
Yeah.
Oh, it won't just.
What percent, or by what would be a difference in percentage between the unemployed people committing felonies and employed people committing felonies?
So only if it asks us for a percentage.
Yeah, only if it asks you to estimate something. Here they're asking you to prove something. They're asking a question. The question
They're
is,
not asking-
are unemployed people more likely to commit a felony than
They're not
unemployed?
asking for like a number, like an estimate.
Right.
Okay.
So that's why we send hypothesis.
Yeah.
Yes. They're asking you a very specific question that you have to answer with,
Makes sense.
you know, yes or no.
Yeah.
you know.
Wait, that's like the confidence?
It's not a confidence.
That's why it's a test.
Confidence is when you said the percentage?
It's
Yeah.
just in essay notes. Like here they're asking straight up like
Yeah, okay. So
or
that's,
unemployed people, like they're asking like the questions. It's like they're not asking it like what if people are likely?
Yeah.
They're like using like
8. Sample 1 has these, sample 2 has these. Okay, so this looks like a test now because they're giving you hypotheses, right? It looks like we're going to have to compute a p-value, so we should go through all of this, or as much of this as necessary. Mu1 minus mu2.
so what were you
Sorry.
saying mean?
Sigma, no, mu of x bar 1 minus x bar 2. That should be equal to 0.
because it's not a confidence interval.
This is not a confidence interval. We're doing a test. We're given a hypothesis, so we have to use the hypothesis here. Sigma x bar 1 minus x bar 2. And I think we'll do this on the calculator also. So let's do this on the calculator. Clear off.
Is the S1
Yep. Okay, we want a square root. We want a fraction bar. S1 is 4. So 4 squared over 32 plus, again, a fraction bar. S2 is 5, so 5 squared over 29. 1.17. Let's clip that and put it in.
Wait, if we're doing a hypothesis test, why aren't we doing
T-star?
HO and HA?
We have HO and HA.
Oh, it is a test.
So are we doing T-star?
Yep. T star. Is that what's next? T star. Ordinarily, we would test the conditions,
Yeah,
but
if it
yeah.
makes sense.
Mhm. So, let's get a degree of freedom first. I think we need a degree of freedom of 28. T star is going to be equal to, and let's do this on the calculator since we have that out.
The X bar 1.
X bar 1 minus X bar 2, yeah. So what do we need? We need a fraction bar. Wait, what is that?
Why did we need the degree of freedom? Because that to actually calculate the
Yeah. Right, so let's clear. We want a fraction bar, right? Fraction bar. What did we get for X bar 1 minus X bar 2? Oh, we didn't, right?
no.
X bar 1 is 12.
Why aren't we using program on our calculator? Because it's
12
not
minus
confidence
9.8.
interval.
12 minus how much? 9.8?
Oh, 2.2. Oh, yeah.
9.8
Minus zero.
minus 0 divided by, what did we get? 1.17? 1.88.
Yeah, I don't get that either.
Was that?
Why do we need the degree of freedom then if we're not using the calculator?
We're gonna use
We are going to use a degree of freedom
For the what?
for the p-value.
Oh, okay.
We just weren't using it right away.
Okay.
Right, so our T star is 1.88. Okay, so let's do a CDF TCDF, the p-value is going to be equal to the probability that t is greater than 1.88. That's going to be equal to, again, let's use the calculator. Since we have the calculator,
TCDF? Right?
I'm trying to figure out, wait, hold on. Yeah, TCDF, do that here?
It's in the distributions.
Yeah.
Second distribution.
Second distribution.
Yeah, I'm trying to get there, hold on.
Second bar. Yeah, second bar.
Second var.
And then what do you call it? TCDF?
TCDF, yeah. And I forgot what numbers we got.
Oh.
We've got
1.88. Thank you. 1E99.
yeah.
And then
28.
Yeah.
All right.
Wait, why was it greater than 1.88?
Greater because our alternative hypothesis on here it says greater. There's my p-value.
Oh, it says it in the question.
Yes, it does. There we go. 0.0353. Yeah, great.
And that's our T. Oh, that's our P value.
Yeah, that's our p-value. Do we need to figure out anything else?
No, that was it.
That's it. Oh, we didn't say test statistic,
what's
but
the
this
value of
this is the test statistic.
1.88.
Test statistic.
And the standard error is 1.17.
Standard error is 1.17, right?
So that's it, right?
That's it. Standard error, test statistic, p-value. We're done. Question 8.
9.
Now we do question 9.
So it's just basically sigma for both, right?
Sigma for both?
For a confidence interval and for a hypothesis time.
Yeah. Okay, confidence interval is not PC.
It's P1.
Confidence interval is not PC.
Oh, and when to use critical, it changes for the proportion and the mean, right?
Was that?
When we should be using critical, it changes depending on whether we have a mean or proportion. Like it's not the same conditions. Like confidence
No.
interval. Oh, it's the same.
Critical is always if you're doing a confidence interval.
Oh, always, whether it is okay.
Okay, so let's do this standard error. That's going to be equal to sigma. Is P1 minus P2, right? Again, I think I'm going to go ahead and do this with the calculator. Let's clear off. And we're going to do a, what is that? Square root, right?
Adam, what'd you come over here?
Okay. Oh, you know, before we do this, we should also figure out P1 and P2, right? P1 equals, was that 13 out of 20? 0.65. P2, 15 out of 19, you said? 78.95. Okay, so we're going to have to keep those numbers in mind. Okay, so 0.65 times 0.35 over 20 plus, this is where I'm going to need you to tell me what it was again.
0.7895.
7895.
Are we doing the S1?
times
Which one
0.2105.
was
Standard error.
0.2105.
Over 19?
What does that say?
Is this for a mean?
This is for proportion. All right, so that's our standard error, 14, 8.
Wait, I have a question. Why was it over 20?
Sample size of the first sample is 20.
Is this the P1, 1 minus P1 over N1?
P1, N1 minus P1 over N1.
Yes.
P2, 1 minus P2 over N2. You said 14, 19, right?
Yeah.
And let's get that screen clip.
Wait, so is P1 13?
P1 was 13 out of 20, which is 0.65.
Oh. And the sample size is 20. What was 15 over 19?
15 over 19 was 0.7895. That's P2.
And for hypothesis test, it's the S squared.
If you're doing a mean
This is a
proportion.
so it's not.
So this is a, so we're doing a hypothesis test.
Yeah.
PC.
Is PC.
First PC.
All right, PC.
That's just critical? That means
No, PC means proportion of the combined.
So you're basically adding both the tops and both the bottoms. So P1.
Yeah, why don't we use the fraction calculator here? Was it 15 and no 13 and 15, right?
Yeah.
13 and 15, 19, no 20 and 19.
Over 20 plus 8.
That's PC. Thanks a lot. 28 divided by 39.
that's our answer?
That's our PC right there. 71, 79.
So can we just do 0.718?
7179.
You want us to
You
roll?
want 4?
4.
Because it's a proportion.
0.7179.
Adam, do this algebra 1 problem for me. There's more steps to it.
I think I'm going to take that approach again because we're going to be using the same thing. But what's 1 minus PC? Well, that's going to be equal to 0.2821.
Wait, what is
So why are we doing 1 minus?
Oh my gosh.
Because that comes out.
Pro-
No, you said like
It's
5
part of the
times, but I
equation.
combined proportion.
So is that the actual
How do
answer?
you find?
No, like for part of the equation for the
Deviations plus each other over the ends plus each other.
What was it? Point.
Thank you very much, Mr. Ray. I feel good.
Wait, so what's the answer?
We're not done yet.
It's over. It's over 9.
We didn't do the answer.
That's the answer.
No, Raya, you're so naive. You're so naive.
I thought she was just kind of saying peace out anyways. Okay, so
Can you scroll up for 1 second?
You feel so much better, right? You didn't even know.
No, I don't feel better anymore. No. The good feeling's gone.
Adam, solve this.
It's all over N, right?
huh?
All over N.
Bro, you can.
We'll get there.
No, you.
Please, Puma wasn't available.
Where is Puma?
He's in Chicago.
What?
Dude, I'm kidding.
What? I'm thinking something today.
Like I just saw him.
Something like an hour ago. He gets to Chicago pretty quick.
I don't know how he's gonna survive there. It is cold.
Dude, it's a really hard school.
Yeah. We're in school.
So many people live in Chicago.
Not
Wait, but
according
the
to
thing is,
Sharon.
we live in Los Angeles. Like, I was thinking about this. I can't apply anywhere on the East Coast because
You never know how much you
Sharon breaks the world into two groups.
It's funny, they do the same thing in New York.
There was that show, they have the show $1 Million Listing LA and then in New York. And then when they come to LA from New York, they're always like talking like really big about like LA. He's like, I always see the nicest cars there. The only thing I could think about is how much are their lease payments?
Okay, let's get the standard error. Is sigma P1 minus P2.
Wait, so what did we just find? PC?
Yeah, we just found PC.
Wait, so why did we do PC times 1 minus PC?
Yeah, you're gonna need that in the formula for
So what is that, like, what do you call that?
just P.
Can you scroll up in one line?
It's in
Thank you.
well, yeah.
Yeah, calculating it now will help you with the calculator, with the next calculator step. So let's do the next calculator step. Okay. Next calculator step is the last calculator step.
Freaking Berkeley, my booty.
That's the square root of. That's not a square root. Square root is that. Now we need a fraction.
Wait, what's over and right?
0.2025. 0.2025 over 20.
So which formula is that?
That's the standard error for the using PC and 1 minus PC.
So that's a totally different equation than the
That's the one, the standard error with the hypothesis test.
Sorry, I forgot to put the fraction bar here. 0.2025 over 19. And that gives us PC. Wow. 1442.
Where did we get the .2025?
That's PC times 1 minus PC.
I thought it was .2825.
Okay.
No, that's just 1 minus PC, but he's times.
Mr. Grace,
Oh,
what-
PC times the minus
Wait, so what formula? What's that called? What are these variables? What is 0.2025? What
That's PC times 1 minus PC.
You use PC.
Oh.
Let me show you what the formula is. This is the formula.
So it's the same as the.
I've heard that before.
Deja vu.
That's the formula.
1442. There we go.
Rhoda, what do you know?
That's our standard
Is that
error.
the answer?
That's our standard error.
All or
Okay, never mind. I'm not
She's
sure
going to
Saturday.
Ohio.
I bet if you want to get A on this.
I'm going to San Diego Saturday. Friday
So we're
night.
going, and I don't know if I'm gonna be home much.
When's our test?
where are you going to camp?
So, and we're gonna finish the second one tomorrow.
What's tomorrow?
Are you sure?
Okay, that's like, okay, yeah, that's fine.
Thank you, everyone.